guess voltage drop isn't a thing anymore, according to this guy and his 30 years of experience. But anyway, I'm plugged into this circuit for a reason. This is the closest circuit to my electrical panel. Home run goes straight to here with 12 gauge, 20 amp circuit. This is the shortest run I have. I've got this heater, which is 1500 watts, plugged into this kilowatt. You see there's my voltage, 120.5. I'll set this to amperage. I'll turn the heater on and let's see what we get. I chose this circuit for a reason because it's short, it's 12 gauge, I shouldn't have any voltage drop. So 1500 watts. It's a resistive load, so as it heats up, resistance changes, our amperage will drop. But let's get a baseline of what our amperage reading is going to be. Let's just say 12.26. How about that? Now I'm running through 73 feet of 16 gauge extension cord. I'm still using the kilowatt. I have the heater plugged into the kilowatt still, same heater. I've added a multimeter taking voltage readings. The kilowatt is taking voltage readings currently, so 120.2, 119.9. And I've added a clamp-on meter to take amperage readings. I can't wait for people to comment about how cheap and crappy this meter is. You might want to Google it. But I'll turn this on to 1500 watts. What do you think my voltage is going to be? Let's calculate this out like you said to do. Now I'm not doing your exact calculation because, well, it wouldn't be possible. You didn't tell me the voltage or what the load was. I will do the standard voltage drop calculation that I showed in that video that you were popping off on, and it should be fairly accurate because we are dealing with a resistive load. My cards only go to 14 gauge, but if you go to table 8, chapter 9 of the NEC, you can see that we can get the circular mills for 16 gauge, 2580. Then we're just gonna plug in our values. 2 times K times I. I'm gonna use the amperage reading that we got from our baseline. Remember, we should have a very accurate reading. That's their shortest run. I didn't wanna just take 1500 watts. I wanted an accurate reading. So that 12.26 times our length, 73 feet, and our circular mills. Now I'm gonna go out on a limb here and assume that math's probably not your strong suit, so I'll work it out for you. And it comes to 8.9498 volts, or about 9 volts that we're dropping. We subtract that from 120 volts, and we're gonna have 111 volts. So here we go, 120.5 volts on that one, 120 volts even, 120.1. I'll turn this heater on. What do you think my voltage is gonna be? We calculated out to 111 volts. I'd say despite your 30 years of experience, voltage drop is a real thing. I just proved it to you. And I proved that the calculation is accurate. We're dealing with resistive load. The calculation was right on. So here's my question to everyone else. Let's play a game. What do you think my amperage is gonna be?